we know that black holes exist. We have photographed them, we have measured their gravity, and we have mapped the ones made of crushed stars and the giants anchoring galaxies. But science doesn't stop at what we can see. The math of the universe predicts objects that are far stranger, far deadlier, and frankly, far more confusing than a simple collapsing star. In this video, we are looking at the black holes that theoretically should exist. From microscopic bombs left over from the Big Bang to objects that might not even be holes at all, we are leaving confirmed reality behind and entering the realm of the impossible. Here are the 9 theoretical monsters that haunt the equations of physicists. 1. Primordial black holes. Now we enter the realm of theory where things get strange. First up, micro or primordial black holes. These are the ancient ones. They didn't form from stars. Stars didn't even exist yet. They formed mere fractions of a second after the Big Bang, born directly from chaotic density fluctuations in the hot, primordial plasma. Visually, you wouldn't see them at all. They are microscopic, smaller than a single atom, yet they pack the incredible mass of Mount Everest into that tiny space. Their lifespan depends heavily on their starting size. The smallest ones evaporate almost instantly, while slightly larger ones might still be lurking today. If we ever find one, it would be the holy grail of physics, proving our theories about inflation and the very early universe. But be careful, you don't die by getting eaten. Because they are so small, they are extremely unstable, and if you got close, it would explode like a nuclear bomb right in your face due to runaway Hawking radiation. The aftermath isn't a hole, but a massive blinding flash of gamma rays. 2. Quasi-Stars. While we know real giants like Tan 618 exist, there is a theoretical monster that might explain how they got so big in the first place. Enter the quasi-star or black hole star. In the early chaotic universe, sometimes a gigantic gas cloud would collapse so violently and with such mass that the core becomes a black hole immediately, while the massive outer layers remain intact as a star. Visually, this would look like a star, but a monstrous reddish one, physically larger than our entire solar system and burning with extreme brightness. It is a zombie star, being eaten alive from the inside out. It's a cannibalistic balance that is doomed to fail. Consequently, its lifespan is incredibly short, lasting only about 7 to 10 million years, a blink of an eye in cosmic terms. Eventually, the outer shell is fully consumed, leaving behind a massive seed for a supermassive black hole. If you visited one, you wouldn't die in the black hole, you would die in the star, vaporized by the unimaginable heat and pressure of the stellar mantle, the ultimate pressure cooker, while the black hole lurks silently beneath your feet, waiting for its meal. 3. Kugelblitz radiation black hole. Next is the sci-fi dream, the Kugelblitz, or ball of lightning. This is the only black hole made of pure light, not matter. It forms either naturally in extreme cosmic events or artificially by an advanced Type 2 or 3 civilization. By concentrating so much raw energy, like lasers or radiation, into one single spot that the energy density itself warps space enough to create an event horizon. Visually, the creation process would be blinding. An impossibly bright point that suddenly collapses into absolute blackness. However, because they are made of trapped radiation, they tend to be incredibly unstable. Their lifespan is likely short, possibly just fractions of a second, as they want to radiate their energy away quickly. You wouldn't survive the attempt to visit one to check its existence. The sheer heat and energy required to create it would vaporize you into plasma long before you ever got close enough to touch the event horizon. If you are enjoying this existential crisis so far, please hit that like button and consider subscribing. It genuinely helps the channel survive against the void. Also, there is a new feature called Hype. If you want to really help this video break out, please go ahead and click that Hype button. It makes a huge difference. 4. Gravastars, the vacuum star. Now, we enter the realm of the imposters. Objects that look like black holes from a distance but break all the known rules upon closer inspection. First up is the Gravastar, or gravitational vacuum star. This theory suggests that when a star collapses, it doesn't form a singularity. Instead, the fabric of space-time undergoes a phase transition like water freezing into ice. The interior becomes filled with dark energy, which exerts an outward pressure that stops the collapse dead in its tracks. Visually, it is the perfect camouflage. From the outside, it looks identical to a black hole's shadow, but the structure is radically different. Instead of an event horizon you can fall through, there is an extremely thin, incredibly hard physical shell of matter. Because of this stable dark energy core, gravastars don't suffer from the information paradox and they don't evaporate away. But for you, the traveler, this is bad news. If you fell toward one expecting a long journey into darkness, you wouldn't fall forever. You would smash onto that hard matter shell like a bug hitting a windshield, dying instantly on impact just millimeters before where the horizon would have been. 5. Planck stars, the quantum bounce. Next, we have a solution from loop quantum gravity called the Planck star. In this model, the star collapses, but quantum mechanics steps in to forbid the singularity. The collapse halts exactly when the star reaches the smallest possible unit of size, the Planck density. At this point, the star doesn't vanish. It bounces back. It effectively turns into an explosion. Here is the mind-bending part. Because gravity is so intense, time dilation is extreme. To us on the outside, this bounce happens in such extreme slow motion that the object looks like a frozen, static black hole for billions of years. But in reality, it is a star in the middle of exploding. Eventually, given enough time, it will expand again, releasing everything it ever swallowed in a phenomenon that looks like a temporary white hole. If you fell in, you would be caught in this time trap. You would fall toward the center, only to be eventually hit and crushed by the bouncing back matter that is essentially coming at you from your own future. 6. Fuzzballs. Then we have the contender from string theory, the fuzzball. This theory argues that the very concept of an empty pit is wrong. According to this, black holes are actually gigantic, incredibly dense balls of vibrating strings, the fundamental building blocks of the universe. Visually, this changes everything. There is no sharp, clean black line defining the event horizon. Instead, the surface is fuzzy and wavering, like a heat haze. The biggest twist is that there is no singularity at the center. The entire volume of the hole is packed full of mass. This structure solves the famous information paradox because the data of what the black hole ate is stored right there on the vibrating strings, eventually radiating back into the universe as the fuzzball dissolves. But for you, it's terrifying. You don't fall in. As soon as you touch that fuzzy surface, you are assimilated. The strong forces disassemble your atoms into pure strings, and you become part of the living fabric of the fuzzball itself. 7. White holes. Finally, we shift into the reverse gear of the cosmos, the white hole. This is a perfectly valid mathematical solution to Einstein's equations, acting as the exact opposite of a black hole. While a black hole eats everything and lets nothing out, a white hole spews matter and light out and lets nothing in. It might be the life after death of a black hole that has finished bouncing back, or perhaps the exit point of a wormhole connected to a black hole elsewhere in the universe. Visually, it would be the antithesis of a shadow, a blindingly bright region of space, erupting with energy. Its lifespan is a mystery. It might exist for only fractions of a second before collapsing back into a black hole. Its existence is controversial because it seemingly violates the second law of thermodynamics by decreasing entropy, bringing order from chaos. And your death? You can't die by falling in. It is physically impossible to enter. If you tried to force your way against the stream, the sheer pressure of the outflowing matter would smash you against the event horizon, pulverizing you into dust. It is the ultimate cosmic ejection. 8. Charged black holes. Now, we arrive at the ones that physics forbids. First up, what if we add electricity? Meet the Reissner-Nordström, or charged black hole. These form if a hole swallows a massive amount of charged matter. Visually, they are bizarre because they possess not one, but two event horizons, an outer one and an inner one. In reality, these are almost impossible because the universe hates charge imbalance. A positive black hole would instantly attract negative particles to neutralize itself. But if one did exist, you wouldn't die from gravity. Electromagnetic forces are billions of times stronger than gravity. Long before you reach the horizon, the immense charge would rip the electrons from your atoms. You would die the ultimate electric shock, vaporized by lightning bolts on a cosmic scale. 9. Naked Singularities. And finally, the ultimate violation of nature. The naked singularity. Imagine a black hole spinning so fast that the centrifugal force becomes stronger than gravity. Theoretically, this could blow the event horizon away entirely, leaving the singularity exposed to the universe. We call this the undressed monster. Visually, this would be a single point of infinite density floating in space, a tear in reality that you can look at with your own eyes, without a black shell hiding it. It is forbidden by the cosmic censorship hypothesis because it breaks the universe. Without an event horizon, the laws of cause and effect dissolve. If you approached one, you would face the loss of causality. You might see your own death before it happens, or witness the end of the universe. The math breaks down so hard that we can't even predict how you die, only that in the presence of a naked singularity, the past, present, and future collide, and reality itself stops making sense. So there you have it. From the stellar corpses that litter our galaxy to the naked singularities that break the laws of physics, the universe is a lot stranger and a lot deadlier than just a dark room. If you enjoyed this descent into madness, let me know in the comments which death you would choose, spaghettification or assimilation. Thanks for watching.